Welcome to our presentation on serials reclassification and metadata remediation, a case study in progress.
Hello, my name is Stephanie Fallett. I'm the Specialized Collections Catalog Librarian and Assistant Professor at the University of Nevada, Las Vegas Libraries. My pronouns are she, her, hers.
Hello, my name is Landon Palushai, and I am the Catalog Data Realignment Project Manager at the UNLV Libraries. My pronouns are he, him, and his. And today we're going to go over two separate but overlapping projects that we have each been working on in the Discovery Services Department at UNLV.
I'm responsible for cataloging materials in UNLV's Special Collections and Archives, which includes periodicals. This project began about 1.5 years ago when I met with the head of Special Collections Technical Services and the head of Discovery Services to discuss some ongoing difficulties that Special Collections staff were having with discovery of Special Collections periodicals, both in the catalog and in the physical stacks. The problem largely stemmed from periodicals being physically shelved by title rather than by call number. Since beginning this project, we've also discovered that multiple titles that had been cataloged separately according to professional cataloging standards had ended up getting housed together in boxes once the physical issues made their way back to special collections stacks. But this wasn't always accurately reflected on the box labels. All of this has led to a lot of confusion for special collections staff. Another problem that was identified was that there was no separate location code in the catalog for either regular sized periodicals or oversized periodicals, even though they were each shelved in separate areas of the special collection stacks. And speaking of stacks management, we have a couple of different areas in the stacks where periodicals have been shelved with no clear rhyme or reason, which has also made physical access and discovery more difficult for special collection staff. After discussing the various problems and potential solutions, it was decided that we would assign Library of Congress call numbers to all periodical titles and create new separate catalog location codes for regular sized periodicals and oversized periodicals. Once we identified a path forward, we decided to start with a mini pilot project. We began with the University Archives periodical titles. There were about 20 or so that needed to be updated or cataloged, so it was a manageable number to start with to test out our workflows. Some have brief records in our local catalog, but many were completely uncatalogued titles. I was able to identify a few record matches in OCLC connection, and the rest required original cataloging. From there, the cataloging process was pretty typical for serials, while making sure to add the Library of Congress call numbers to the records. Doing a mini pilot project was a good place to start to figure out a manageable workflow between special collections and discovery services and back. Once the university archives titles were complete, we moved on to regular special collections periodicals. The head of Discovery Services had generated a spreadsheet of all the periodical titles in special collections, and we decided to start with titles that had OCLC numbers, thinking or hoping that they might have better records or would require less work. That turned out to be mixed. Some of the more mainstream popular titles had more robust records, either in our local catalog already or in OCLC that could be copy cataloged. But many of the more obscure titles needed updating, at least with Library of Congress call numbers or original records needed to be created. If our existing catalog record was good enough and the OCLC numbers matched with the correct OCLC record, I would simply add the Library of Congress call numbers based on the records themselves, using subjects, for example, in the interest of expediency. But some of our local records were so brief that I needed to look at the physical items to verify what exactly we had in hand so I could either match to an OCLC record or determine that original cataloging was needed. This was the case when I got a or this was also the case when I suspected a mismatch in OCLC numbers in our titles. Common titles often got mismatched with the wrong OCLC number. So these needed to be fixed or set aside for original cataloging if I couldn't find the correct match in OCLC. So this is the step that we're at now, which we started a couple of months ago. Going back to our master spreadsheet of titles, we're now tackling the ones without OCLC numbers. These have usually been extremely brief records in our local cataloged. Oftentimes I found that it's just the title, so looking at the physical issues has been essential. I always check to see if I can find a record match in OCLC, but when I don't, I create original records in connection. I will update the records as needed or create original records in OCLC and add the local call numbers, which I then import or overlay over our existing local catalog records. I update the holdings with the new location code and add call numbers at this point. But at this point, I don't do anything with the item records. This is where the catalog data realignment project comes in, which is what Landon will go over next. So I will pass it over to Landon to talk about his project. At this point, I don't do any. Oh, but at this point, I don't do anything with the item records. This is where the catalog data realignment project comes in, which is what Landon will go over next. So I will pass it over to Landon to talk about his project.
So for some background on the catalog data realignment project, this project encompasses several data integrity issues that were identified after UNLV's ILS migration from Millennium to Ex Libris Alma, which happened at the end of 2017. The issues were identified by the head of Discovery Services, and they were ranked in order of priority according to several factors, including impact on discovery and access, obstruction of day-to-day staff workflows, accuracy of bibliographic reporting, and increasing interoperability with external systems. So some of the phases of the project include separating multi-format bibliographic records to align with current cataloging practices, removing auto-created host bibliographic records that were added by Alma during the migration process, cleaning up Library of Congress style call numbers that are in either local or item call number fields. And as this presentation will focus on creating item records for special collections periodicals. So some of the constraints that we're working with include having a team consisting of temporary part-time staff members, and also this is a time-based project that is reliant on funding. So the problem that we're trying to solve with this portion of the project is that discovery and access to special collections periodicals is very limited. The holdings ranges, if they are present, are inconsistent across all titles, and patrons currently cannot see the range of items that we have in our collections. So this also affects the public services ability to assist patrons. So the goal is to make special collections periodicals discoverable in the library catalog at the item level. So this provides patrons with more complete information needed to carry out their research, and also public services will know exactly what we have, and they can answer queries and pull items for patrons more efficiently. So currently, all of the special collections periodicals are listed in our local catalog. However, as we mentioned, the level of description is inconsistent and incomplete. So periodicals that haven't yet been worked on by these two projects currently only have one placeholder item record in the catalog, as opposed to the other image on the slide where that's a completed title that has all of the item records in our local catalog. So after the titles have been assigned a Library of Congress call number, the process to create the item records is as follows. My team creates an item list following in-house documentation. This documentation was adapted from the previous process that Special Collections had created to have their student assistants work on periodicals inventory. The documentation includes things like where to find the enumeration on the physical items, how to transcribe that information, how to spot a potential title change, and how to identify supplements. And we use Google Sheets to record the item data. So after that, I review the spreadsheet for accuracy, and this step is where the process can either go very quickly or it can get stalled and need a lot more work. If the enumeration of items is straightforward, we can go directly to creating the item records. Otherwise, more work is needed. So this includes checking things like identifying supplements, possible title changes, and inconsistencies or missing enumeration. So these first two steps take the majority of the total time that it takes to complete this process. Um, if there are fewer than 10 items, the staff members will manually create the item records in Alma. And if there are more than 10 items, I will perform a batch upload to Alma using a custom import profile. And to do this, I download the Google Sheet as an Excel file, replace the header row to reflect only the mark tags, and remove any local notes. And then after the batch upload, I run a job in Alma to rebuild the physical description of the items. And then lastly, I check the placeholder item record for any relevant notes that it may have, such as gift notes, and then withdraw that. So next, we will talk about some of the challenges that we've encountered so far.
So we certainly anticipated that there would be challenges when we started these two projects, but some weren't fully realized until the projects were underway. Um, For me, one of the biggest challenges has been my lack of serials cataloging experience. While I am an experienced rare book cataloger, I had never cataloged a serial before. So I took Library Juice Academy's serials cataloging course and am continuing to learn as I go.
And most of the staff members on my team have little to no library experience, so this has involved lots of training up front as well as a lot of learning on the job. And I myself am very new to cataloging, so this I've been learning more about cataloging in general as well as practices that are specific to serials. And this has been an ongoing process for the past several months.
Another challenge has been competing priorities. There is one cataloger for special collections materials, me. And in addition to this periodicals project, Special Collections also has other priority projects and collections that need cataloging. So I end up just being able to devote about 1 day a week to this project.
And the Special Collections Periodicals project, as I mentioned earlier, is just one aspect of the larger data realignment project. So we're balancing the time we spend working on this with all of the other priorities and tasks that we have going on at any given time.
And another challenge has been the number of titles that need work. On our spreadsheet, we've got about 970 unique periodical titles, many of which are quite niche of local Las Vegas or Nevada specific subject interest, such as gambling, casinos, hospitality. So I've ended up needing to do quite a bit of original cataloging, which takes more time.
So another challenge is that sometimes the boxes are mislabeled. And so this has led to special collection staff having problems finding the titles on the shelf for cataloging. So for example, there could be 3 bibliographic records in ALMA that represent title changes, according to the serial's title change rules, but there is only one box on the shelf because the title changes were all housed together. And then also the box label only has one title listed. So this initially led to a lot of confusion, but once we realized what was happening, we started to check the boxes for multiple titles housed together before marking them as unable to locate. So not only did we find multiple titles housed together, but there have also been a couple of instances where title changes were actually interfiled with each other, but had not been cataloged separately, such as the case with the examples on this slide, where the quarterly editions were placed within the general print run of another title. So this also created confusion when my team was creating the item lists. So sometimes the title changes were identified by the temporary staff as they were going through the boxes, and other times I noticed variations in enumeration within one spreadsheet, went to the stacks to verify what was going on, and then I notified Stephanie after sorting things out. So next, we will wrap this up by discussing collaboration and communication.
I've realized that it's been important to communicate some basics of serials cataloging policies to special collections staff who are archivists, particularly with regards to title changes, as major title changes get different bibliographic records. And this is important for staff to be aware of for both online and physical discovery and access of serials titles.
So another aspect that requires collaboration is physically working with the special collections items. So our departments are located in different areas of the library, and special collections items have different policies regarding handling and security. So we have to take all of this into account, both when it comes to training and then when we're actually working with the items. We are also often working in their space, so communication is important to make sure that we're not impeding any of their daily activities. And at the end of all this work, the boxes go back to the special collection stacks where they get call number labels. And some boxes also get new box labels reflecting the correct titles and date ranges if needed.
So both projects that Landon and I discussed are currently in progress. We're continuing to learn as we go and make adjustments to our workflows as needed. We also continue to meet periodically with the head of Special Collections Technical Services to go over any issues or concerns that have come up.
So thank you all for listening, and please feel free to reach out with any questions or comments.
Thank you.
Wonderful. Thank you so much. Great presentation. As a reminder, please put questions for our presenters in the chat or use the Q&A feature, and we'll have discussion time at the end of this block. Up next, I'm happy to turn things over to Jamie for her presentation.
Hi, thank you. So My name is Jamie Carlstone, and I'm going to talk about my workflow for enhancing MARC records. And I'm going to share my screen. Okay. I only have a couple slides because most of this presentation is going to be demonstrations. I did want to acknowledge the team that made this project possible. They were most of the actual work that was done with data enhancement was done by me and OpenRefine and Alma, but this group had a lot to do with the decision making about the project and all the choices that we made about the metadata. So I'm going to put this in the chat if folks want to follow along or want to reference it, because I'm going to do most of this presentation in Jupyter Notebook or in OpenRefine. Okay, now Zoom is doing the thing where it hides the information that you actually need. Okay. So Northwestern Libraries uses Ex Libris products, including Alma for our library management system and Primo for our discovery system. However, this could be adapted to any system, I think, that uses MARC records. So within Northwestern, we have the Hershkovitz Library of African Studies, which contains over 200,000 physical items. Many of these items are in African languages. The MARC record historically uses the ISO 639-2 language code. For many African languages, the ISO 639-2 code uses the language families instead of the specific language. So you can see the list here, the language families that are represented in the Africana library. This fails to capture the linguistic diversity of Africa. And the example that I'll often use is that Klingon is a language in the 639-2 code list, but a lot of African languages are not represented. So this also means for our users, the language that appears in the Primo facet and display is the broad language family. So in this example here, we see that Niger Kordofanian other is the language. So this is from the MARC fixed field. So it comes from that -2 code. So that's what appears in the record. And this is an example of what this record looks like in MARC. So in yellow, we have the broad language code. So fortunately, the PCC recently released the guidelines for the use of ISO 639-3 language codes in MARC records. So this list has 7,916 languages compared to 487 in the -2 list. We also wanted to use this as a test case for adding linked data to records. We decided to add add 041 fields with links to information about the languages. So I'm going to show what this looks like towards the end of the presentation. So if we look at that MARC record again, we can see in blue that the information about the granular language exists. It's just not in the form of a code that's going to be used in the facet or the record display. Since this information is already in the record, it is a matter of converting the data seen in blue to a -3 code so it can be added back into the records according to the new guidelines. So the strategy I use for doing this is to convert the MARC data to CSV, manipulate the data in OpenRefine to get the codes, and then they add the codes back to the MARC data and import the new records to merge with the old in Alma. So to do the CSV conversion, I use the Export tab delimited records tool in MARCEdit. The fields I exported were the ones that might have language information, plus the record identifier, so everything can be merged again. So I have a second notebook that goes through the steps here, which you can reference later if you want, but I'm going to actually jump into OpenRefine and very quickly run through the steps. So with the limited time, I'm going to breeze through these. The most important part is how I will use the reconciliation tool to add the codes. OpenRefine also has this handy sidebar where you can undo the steps. So I'm going to sort of use this in an unusual way for the presentation. I'm just going to backtrack all the steps and then jump through them again. And this was going to skip all the processing times. So I'm just going to go all the way to the top. Okay, so this is what it would look like when you import the data, and this is a test set of 100 records. The most consistent source for the granular language is the LCSH. That's over here in the 650, but MARC records often have multiple subjects. So MARCEdit will combine duplicate tags into one field, so separated by a semicolon. So I split the cells at the semicolon, so each subject has its own line. I then fill down the data from the record identifier so I don't lose any of that vital information. So each subject is linked to the record that it came from. So I then use regular expression to make a new column, which is just the language. And I don't have time to get into like regular expressions here today, but they're very useful in OpenRefine. So we see that the language appears in this subject column here, and it's very clean. This is vital because the Wikidata reconciliation needs to have like a clean list of language names. So to reconcile, you need to just like hit I'm not going to actually do it again, but you go with menu, reconcile, start reconciling, select the actual database you want to reconcile against, which in this case is Wikidata. And of course, it's thinking. And I'm not going to run this, but I would start reconciling. But I can skip that step because I already did it. So we can see the languages here are all now linked to Wikidata. I can even click on them and it'll jump to the Wikidata record. So this is really important because if you scroll down to the identifier section of Wikidata, it has the 639-3 code. So first I want to say that Wikidata will always require manual work with the reconciliation tool. If the reconciliation is not sure, it will provide a few guesses. So you can see what that looks like here, where it's like not sure. So it gives you a few options. It is easy to click over to Wikidata and sort of check the guesses to see if they're the right ones. And then you select the checkbox if you want to say you want to match the cells. So it's a very handy tool. Occasionally it requires a little bit more searching in like Wikidata or Google, and some situations are not as clear, like there's not always an agreement on what to call a language, or there's two languages with the same name, or some other complications. So all these steps that I'm going to skip now are just like manual work that are involved in just making sure that the reconciliations are correct and helping Wikidata with the judgments. And I know it seems like a lot of steps, but it doesn't actually take that long once you get going. So I made sure that all 100 of the records either had at least one language, or I indicated that there was actually no code to match, because there's not always, like in this example here, there's not always an actual language code. This is because I'm going to add a note to all the records, so I know that it's been reviewed. So this is the part where reconciliation to Wikidata really matters. It allows you to add columns of data to OpenRefine from the Wikidata items. So I'm going to jump to the next step here. And so in this example, I added the country information from the language, which is not really needed for this project, but it actually helps check to make sure that the matches are correct. Like if there's a country in here that's not in Africa, it's probably not the right language. So the next bit of data that I'd want to pull in is the actual language code. So that's right here. And then I formatted the data for the PCC guidelines by adding a column that formats the code for MARC. So that's what this one is right here. So we also wanted to add link data into the record too. So this part was not part of the PCC guidelines, but it was something that we wanted to try Northwestern. So we just kind of made something up. So in order to do this, I added a column for the Wikidata column identifier. So this is the actual identifier that the Wikidata record has. So you see it at the end of the URL. And then I revised that to be the actual URL, so it can go into the record as linked data. And then I did something similar with this ISO ISO 639-3.sill.org link. So this is the organization that's actually tasked with maintaining the codes. So this was easy to build because it uses the code in the URI. So the final step in Refine is to add the note field to each record. This is so I know that the record was already reviewed. So this is going to be, in our system, we use the 949 for internal notes that something has been revised. So I'm going to jump back to my last notebook here and just finish up. Talk about actually adding the codes back into the records. So I added the codes information back into Alma by first using some more MarcEdit tools. So first, the OpenRefine project needs to be exported into an Excel table, and it needs this in the MMS ID, which is what we call it in Alma, the unique identifier for the record, so that it can match. And then it's all this additional information. So I use the tab delimited file can be converted into MARC data using the delimited text translator tool here. This builds a file of MARC data that is just the information from OpenRefine plus those unique identifiers. So then this MARC file, which looks like this, can be merged with the original export of the MARC records using the merge record data tool. So at this point, the records can be imported back to Alma by merging with the existing records using, the Alma import tools. So my colleague created a rule in Primo that added the -3 code to the language display. So we also came up with this language to display the linked data. I'll show what that looks like. So right here, it says language details and it says link opens a new tab so that it's clear that it's leaving our system. And then we also have a second one for the SIL.org website. And Wikidata is great because it has lots of information in the record, but it is like open source, so it's not necessarily correct. But the SIL one has less information, but it's like the official people who run the codes, so it's more reliable. So we thought it was good to have both. And so with that, I'm just going to add that after we did the original group, we realized that there are more records that could benefit from the codes, but did not have a language in the fix field. So for example, if there are MARC records that had a blank language code, but a subject heading that described the language. So I've been working on identifying all the remaining Africana records that could use this work. And with that, I'm going to stop sharing my screen. And thank you very much.
Fantastic. Thank you so much. Thank you for taking us through your Jupyter Notebook and showing us OpenRefine in action. That was a wonderful demo. Many thanks to you and Stephanie and Landon, two really powerful and wonderfully detailed presentations. So we will be looking at the chat and Q&A. We're getting a lot of amazings and thank yous, which is of course no surprise because y'all are awesome. While folks refine their questions for you, I'm just curious about, because this work is so important, cleaning up the metadata, reconciling these fields, doing these kinds of projects, has a lot of consequences across an institution, but sometimes it can be hard to get that impact across to decision makers. So I'm just curious about kind of where the support for your respective projects comes from, if, like your respective deans and directors are really keen on it, or if you have to kind of champion for these projects and get the buy-in from kind of the kind of more senior management. I'm just curious how this works with your organizations.
I don't know. I was actually thinking, Landon, I don't know if you would want to say a little bit about your project, because it is like kind of a specially funded project. So it was something that we had to get kind of institutional buy-in for. Do you have a bit of background, Landon, that you could talk about?
Sure. Yeah, so I guess they've been like identifying these issues throughout the time that's happened since the migration, and the money actually comes from a donor, and the donor was a cataloger here at UNLV Libraries for almost her whole career, I think. So that's how my project is funded. And so right now, I'm on a 2-year contract, so we're funded for 2 years with 4 temporary staff members and myself. So we're trying to knock out as many of the top priorities as we can in that time.
Great. Very interesting. I love that the former cataloger is the donor. It's a very satisfying narrative.
We, definitely communicated with our Africana librarians, the people running the Africana library, and they were very supportive um, of the project and enthusiastic about it. And then we presented this to our like monthly liaisons meeting, which is like the librarians who tend to be like subject specialists, and they all find it interesting. And we made sure, communicate that if they had like other ideas for other language areas that they wanted to see this work to let us know. I'm not sure we actually would have like another area where it would be this valuable just because Africa is like so distinct both like linguistically and our collection. But we've communicated that out to the library, and um, everyone's very supportive of it. I think everyone finds the little Wikidata reconciliation to be neat.
It's very cool. I'm glad its value is being recognized. We have some questions that have come in from chat. Elizabeth McDonald asks, are you able to update the OCLC records?
This is probably for me, right?
Yes, I believe
Yeah.
so.
I did not update the OCLC records. I have a hesitancy to do that when I'm being tricky with Wikidata and OpenRefine and MarcEdit. And also we took the PCC guidelines, and then we also like did our own thing with adding the linked data, which is not in the guidelines and probably not a proper use of the 041 field. Um, but also, a lot of these records are these Africana conference papers that we have here, and they're not in OCLC also. So that's like probably a pretty substantial chunk of them wouldn't even be in OCLC. And then I think the next question is for me as well, that Steve asked. So could this process have occurred without the record export from ALMA, assuming the config and MarcEdit might support such a large scale process? I've actually I've never done like the actual, I know we can do like the MarcEdit integration. And I'm always just like, I always just pull the records from the system. I've just been doing this for like so many years. I'm like stuck in my ways. And I like do all the manipulation stuff like in MarcEdit or OpenRefine. And then I just do import back and merge it. And I know I'm like, I'd probably love it if I like actually set this up, and I should. I just haven't. And I've done other things with the Alma like bibliographic API, and I could probably like push. I've done other things like call number updates with the Alma APIs. Obviously that's the Holdings API, but not the bibliographic one. But probably, I think it's really like what I said before is like I think any system that uses Mark, where you could update Mark records in batch, you could do this.
Awesome. Great. Thank you for the question, Steve, and the wonderful answer, Jamie. Any other questions for our panelists? Keeping an eye on our chat. I have a very quick question for you, Jamie. I appreciated the discovery layer aspect and how these languages can be more visible through that avenue as well. Are the languages searchable in Discovery? Is that a searchable field in your Discovery index?
It's by keyword.
Okay.
Yeah.
That's great, though.
Yeah. It
Yeah.
is great. Yeah, and it displays better now. In the Hershkovitz library display, it's more predominant. So
Great. While I'm monitoring, oh, looks like we've got another question. Oh, yes, that's a great point. The communication of UNLV between archivists, special collections, and other parts of the organization. Yeah, that's very impressive. Do you have anything you'd like to add to that collaborative
Hmm.
dynamic? Any comments about that?
There's Go ahead, Stephanie.
Oh, I was going to say, yeah, I have found it to be really important. Like a lot of us are actually pretty new. I mean, I've just been at UNLV for a little over 3 years myself, and the head of technical special collections technical services has been there a little bit longer than me, but is also relatively new. And we have had lots of conversations that I think a lot of the confusion and problems that exist now are maybe due to previous lack of communication between the departments, maybe going back a decade or multiple decades ago. So I found that to be a really important part of the process, so that hopefully we can avoid this going forward or any future confusion.
That's great. I love how a project like this can be a catalyst for organizational change and yeah, maybe getting some silos to be less siloed. Yep. Awesome. Well, thank you again so much. Really wonderful talks. We have a lot to think about, a lot to digest. Really delighted with all of the expertise and knowledge that you all have shared with us. So thank you very much for your wonderful presentations and your great work. We will be taking a break. The next session will begin at 4 p.m. Here in this Zoom room. So please enjoy a little time away from screens, and we will see you shortly for the next round of sessions.
Thank you.
Thank you. Hello, everybody. We're about ready to resume our programming in a few moments here. Our next session is very exciting. Well, all of our sessions have been very exciting, but up next we have Wilhelmina. Are you ready to share your screen for any slides?
Yep. So y'all should see my screen now.
Yes, looks beautiful.
Okay.
Yeah, we can give folks another moment or two just to return from their break. But looks like we are in good shape. And just as a heads up, this is your session. So your presentation and Q&A will be in this block with no other speakers scheduled. So. Okay.
Yeah, I'll go ahead and get started.
Perfect.
So I am Wilhelmina Ranke. I use Mina for short, so that's my easy name. and I'm currently head of Libraries, Technologies, and Systems at Georgia Southern University Libraries. Today, I'll talk about artificial intelligence, history, and libraries. It's a little bit of the legacy and how to uncover past machine learning projects in libraries. So first off, we know there's a lot of buzz about artificial intelligence. With all the intense buzz right now, what is really new? It could be that hype is what is new. That is the 2023 Gartner Hype Cycle. And right there at peak hype, right at the very, very top, there is generative artificial intelligence and artificial intelligence augmented software engineering. So we are at peak hype. Right now, many companies claim that their software is doing artificial intelligence, claim that their software is integrating artificial intelligence, and they've rebranded existing products as artificial intelligence. It's so hyped up. I'm here now with artificial intelligence in the the title of my talk. So we're definitely at peak hype right now. Oh, it opened the link. Sorry about that. So what is really new is at the speed and scale. Who knows what this is? So that's actually a fractal, and specifically it's a Julia set. The math equation behind this was published in 1918. So more than 100 years ago. It wasn't possible to actually implement the math and run that equation until the 1980s with computers. And someone put Mandelbrot set in the chat. Mandelbrot in the 1980s was a mathematician working with computer programs, and he had gone back and found publications about fractals and realized that now we can actually run these. So fractal is a line that retraces itself. So it'll have maybe like bumps on a segment, and each of those straight line bumps then can be retraced with that same pattern. So it's basically a line that recursively retraces itself to infinity. And the mathematical idea is that you have a one-dimensional line which eventually has volume. People in 1918 could just do like thought experiments about it, but if they actually tried to have artists do like retracing a line with recursively many times, they couldn't really get past retracing it like 20 times before just little errors built up and it kind of didn't really look very crisp. In the 1980s with computers, they had advanced enough that math could take and run those equations. So they could retrace the line thousands of times and go through thousands of iterations of recursion with these equations. And the result is things like this. So like Julia set, and someone put in chat Mandelbrot set. Today, fractals are used for all kinds of graphics applications, like making realistic looking hair and computer applications. But it's an example where all of the actual technology was developed and laid out or all of the actual math was actually developed and laid out way before people could use it. So advances in hardware made something new. A kind of analogous thing might be, or an example of how that might play out with machine learning in libraries is like, imagine you have a collection of about 4,000 newspapers and you say, oh, I would like to have machine learning go through and actually index those for me. So pull out the title, the author, the full text, and then do like a Met Salto where you can highlight on the page where that article is and highlight, continued on page 5 and go between those so that you can maybe see the computer like text in a text format over here, and then you see how it appears on the page and you see any pictures or any fonts or anything there. And you say, okay, that's my metadata project. And you get everything calibrated and you say, okay, I'm going to do a test case. And I do my absolute shortest, smallest newspaper, so something that had not even a 1-year run. So maybe 300 issues. And you set your machine learning chugging away, and you get great results. But it took a year to do it. So doing your whole digital library would not just be 4,000 years because you ran that on your smallest newspaper. It would actually, when you do the math, be like 40,000 years of like a really specced out nice computer with a graphics card. If that happens, like you're never going to do it. Like even if you bought 100 computers, like it's still too much time to do it. Meanwhile, when hardware's advanced, if you go through and you do your test newspaper, so your smallest newspaper out of there, and it runs overnight, and you calculate out and see, oh, well, doing my whole collection would maybe be, a couple of years. And if I buy 4 computers, then it's like 6 months. You're probably going to do it because suddenly it's feasible, and it's also cheaper and faster than having a person do it. So it may be that advances in speed and scale of things is actually what's new, and we might have hit a tipping point. Then there's what is really new? Is it culture and attitudes? This is a diagram of definitions of artificial intelligence from the Government Accountability Office. And first wave of artificial intelligence was expert systems. So the idea was that looking at large amounts of information and kind of finding patterns in them, that was very base. And actually what makes us people is our ability to reason and do logic. So the idea of an expert system is there are written down perfect rules that a person designs, and then the software brings things through those perfect rules. With machine learning, so the second wave of artificial intelligence where we are now, the idea is a piece of software looks at lots and lots of data in a training set, looks for patterns, finds patterns. Then after it's been trained, that algorithm can look at something new and make a prediction about it. So say, okay, I've looked at this article and now I'm going to write a summary. So predict this is an accurate summary of it. I've taken this prompt for what a picture should be, and I'll make like a prediction. This is the picture you want to see. Fundamentally, if you don't actually know that much about computers, a big difference in how you might experience these is the level of explainability. So an expert system starts with a flow chart, and it's supposed to perfectly implement that flow chart. And even if you don't really know anything about computers, you can look at the flow chart and know what it's doing. Meanwhile, a machine learning system, it has an algorithm that runs, then it has a training set of data. The algorithm is perhaps more complicated to where you might have to know a bit more about computers to follow it. And then once it's been trained on a set of data and it looks at new data and does something to understand why it did something, you have to dig into the data it was trained on. So the process of trying to understand what it did or explain what it did quickly becomes really complicated. Fundamentally, if you are not coming from the tech side, the difference between these is the level of explainability. And it might be that some cultures would have a problem with that. This diagram gives a really interesting explanation of, for example, of expert systems. So online tax preparation. That's something where the way in which that was implemented in a system that's fundamentally really explainable, when we experience it as the public, it's not explainable. And it's exemplary of so many processes that we've seen in computers that don't involve machine learning. So in the foreground, there's a screenshot of TurboTax, right? So in TurboTax, if I go through it and you go through it, we will get different questions because there is skip logic built into it. As it turns out, the IRS actually still publishes a paper form and paper instructions, and those have the skip logic like printed out on them. So if we were both to do our taxes with a paper form, we would see the exact same thing. We would see the skip logic. We would see all the logic there. When we do it in computer, we see different things and we don't see the skip logic. If we wanted to actually like recreate the form from the computer program, it would be so much reverse engineering. So even though it's a very explainable program, the way we experience it is not explainable. In the case of taxes, there's still a paper form and a flowchart that's published. That's really unusual. Think about applying for unemployment with a state agency. Most of the state agencies do not have paper forms. That was a problem at the start of COVID. Think about every online form you fill out, like if you're applying for a credit card, anything like that. Even if there is a hard and fast rubric or algorithm that is applied to that, so a rubric where it's just like a checklist or like a flow chart that's applied to your data, the way that you experience it is basically you're not going to get an explanation. Like it's going to be a trade secret or just hidden from you. Then we have cloud computing and trade secrets. It's really common for libraries to not get access to basic information about how software we use daily works and to not be able to share information about software freely. So we can't even share like how much things cost. Even if software is explainable, contracts may prevent us from talking about it. And in our daily and professional lives, we tend to use a lot of cloud-based software where features will just change and we find out because we log in and they've changed. So as a society, we've been forced to not get explanations for things for so long that it kind of now maybe doesn't matter that machine learning is not super explainable, since even if it were an expert system or something like based on a rubric, we still would not get the explanation. The premise of my talk is that machine learning in libraries is not so new. I have here 3 open source toolkits for machine learning. I picked those because they're cited in a recent governmental report, the National Artificial Intelligence Research and Development Strategic Plan from 2019. And one of the things that it said is the US should have more of these. These are great. They help people to make advances. And here are 3 examples, but there are many, many of them. So these are like not cherry-picked examples. These are examples from a governmental report. Now in the chat, if you don't already know, when would you guess that these toolkits cited in this 2019 report were first released? So just put some guess dates in the chat. Yes, people are saying 1990s and 1970s. So you're very, very educated. So in this case, these 3 that were just at random in a government report, right? So I did not cherry pick them. Weka was released for download in 1997. Mallet was released for download in 2002, and OpenLP was released for download in 2004. The software, all of them existed before that within private research groups or research groups in universities that were using it. And then that was the date at which they made it available where anyone in the world could download it. And in looking at these, I kind of went and looked for other machine learning toolkits. So other toolkits, proprietary and paid and open source, and got dates for them. So General Architecture for Text Engineering, first released for download in 1995. RapidMiner, released for sale in 2001 as yet another learning environment. SPSS Modeler releases Clementine in 1994. SAS released for sale in 1972. And Infinite Insight released for sale in 1998. And KNIME released for sale in 2006. So they are all around 20 years old or older. That is the state of open source machine learning. There may be newer things, but there was quite a lot of software, and there's a big chunk of it that is 20 years old or older. Those initial release dates are pretty long in the tooth. Not all of those did machine learning as we describe it today, maybe back in the 70s, but at least for the 1980s and 1990s with data mining, the concept of looking at lots and lots of data, then using that to make a prediction about a new thing was a thing, and there was software to do it. There are 2 old buzzwords with a similar concept, data mining and big data, that if you go back and you look for information about machine learning, instead of being called artificial intelligence, maybe is called something else. I have here this definition of artificial intelligence from Atlas of AI that gets some of the fluidity of the definition. So the phrase has moved in and out of fashion over the decades and is used more in marketing than by researchers. Machine learning is more commonly used in the technical literature, yet the nomenclature of AI is often embraced during funding application season when venture capitalists come bearing checkbooks, or when researchers are seeking press attention for a new scientific result. As a result, the term is both used and rejected in ways that keep its meaning in flux. So artificial intelligence has a fluid meaning. We have past buzzwords. The Gartner Peak Hype Cycle item in 2013 was big data. So same concept, look at lots of data and then use it. Then we have older literature using text mining, data mining, and predictive coding. So researching artificial intelligence in libraries is not super fruitful, but then we have all these toolkits that are 20 years old or more. So the meaning of artificial intelligence has changed over time from expert systems to machine learning, but these toolkits are older. One way you can uncover past literature about specific issues you want to look into in library use of artificial intelligence is to look for specific toolkits as part of your search when you're researching those problems. So put in things about the problem you want to find and then older toolkits. So for example, there's general architecture for text engineering in Dublin Core, and it looks like there's some resources here about maybe metadata creation, OpenNLP, MARC, and subject headings, and it looks like there are resources about using machine learning to generate metadata. Then I went through and just kind of found like example uses, and these are not key papers, right? This is just kind of looking for like specific toolkits and looking for things about academic libraries. So like terms like university library or looking in library and information science full text, and got past examples of ways machine learning has been used in libraries. So optical character recognition, it's really huge today, and that existed since the 1960s. In that same paper about optical character recognition uses, there was a desire expressed or some discussion of using machine learning to pull out metadata fields from a digitized form. So have like a scanned in card catalog and actually make the MARC record instead of just identify the text and someone key it out. That is still very, very relevant today. So I have a screenshot of one of the finding aids at Georgia Southern University. We do not have a system that can handle EAD XML. So we have our stuff represented, but it's more represented in text files that are not super worked. It's not just a PDF. We have a PDF uploaded and we have Google Docs. So it is like textual, but it's not in XML. And so being able to convert from a PDF with fields that are like, bolded and laid out for people, but not marked up for a computer, and take that and put it into metadata that's clean in a computer, that's something I think that we have all worked with before and something that machine learning could be used to assist with. Tagging names of people, places, and organizations in documents. Entity ranking, so being able to run a search for a topic and not just find like, papers about that topic, but instead find ranked, here are the people doing research in that area, here are the organizations doing research in that area. There's just a random paper about that, and then that's something we actually have the ability to do today in Web of Science. Being able to rank the readability of different texts from hard to easy and give them a readability score. There's just like a random site to a library use of doing that for a digital library. And then it's built into Microsoft Word today, where I ran it on my abstract for this presentation. Tagging subject headings. So going through text and tagging subject headings where maybe you can use that to make a browsable interface so someone can browse between related documents. So subject headings and uncontrolled, but they would be controlled within like your own system. Locating citations in a piece of text. So there's just a random site about a project for taking text that's not marked up in any way and going through and flagging everywhere where a citation exists. And then I have a screenshot from Westlaw where that's actually done and it's hot linked. I believe that used to be done by people and now is done with like pattern recognition. But it's certainly something that is done in electronic databases that we use in library science, where the vendor has software that will parse and find citations in it. Recognizing the author's emotions at the time of writing. So I have like a random 2009 library science field study or information science field study about recognizing emotions. And I have some real world examples of that. So Facebook has used similar concepts to manipulate the news feed. Recognizing emotions based on cell phone use patterns. So there's an information science study about that, and many more. I found all of these by just searching for names of specific machine learning toolkits and then academic library terms. So like MARC or Qualified Dublin Core. I bet that if you have a problem to solve at work, and you want to find whether machine learning has ever been applied to this in libraries, that you can search for terms related to your problem, and then search for specific machine learning toolkits to see whether there's been examples of research done in that area. And you'll probably find something maybe even from decades ago. The other thing is that today, in our current hype, we are dealing with cloud-based artificial intelligence. A difference between now and those past studies is that with something like ChatGPT, you can only use it with one at a time copy pasting into an interface or with a paid API. So you never actually have access to the algorithm. And to do anything at scale, you pay a fee. And you pay like a put a coin in the meter kind of fee. Consider that current hype around artificial intelligence might be a step backwards, and that generative artificial intelligence tends to be centrally controlled by large corporations. Older literature on machine learning might be something you could implement rather than using a paid API to a large corporate system. Then contributions of libraries to machine learning. One way libraries have contributed is by having lots of words. So really, really early machine learning projects in the 1960s and 70s were oriented around just trying to find a lot of words in computerized format. Before email and things like that, it was really hard to find them. And actually, what they used was government documents. They tended to use things like the U.S. Patent Office had digitized its records really, really early in the 1960s, and then the Federal Register had digital versions of its material. But GODORT, Government Documents Roundtable, is part of the American Library Association. Then moving on into the 1980s and 1990s, academic libraries and the library field had full text abstract searches and had Gopher files of journal papers and tended to have like large amounts of words early. Today we have lots of user-generated content. So for example, Reddit has lots of user-generated content. When machine learning was developing, getting lots of words was a challenge. And the library is also unique in that it's fundamentally not just about having lots of words. It's also about the book content being high quality and about being able to find specific items there. So there's some dovetailing between machine learnings and libraries over the history of artificial intelligence. The next is ontologies. So an ontology is a representation of the formal relationship between things. A good analogy is like a thesaurus, or a classification system. So you can imagine how like some machine learning algorithm looking at a lot of text, if it's trying to guess, okay, here are related terms, you can give it a jump start by giving it some representation of how terms are related. So you can give it things like, here are synonyms for something, here are relationships between terms, here are the names of organizations and structures, here are the names of governmental structures and how they relate to one another. And by giving it those relationships and combining that with pattern recognition, you get better results than if you just do pattern recognition with without any kind of contextual information. So machine learning algorithms really get a boost by having some sort of predefined relationships in the form of an ontology. And ontologies and classification systems, library science is one of the fields that has developed those, and especially the linked data community. The last way libraries help is provenance. So I have screenshots there of ImageNet. ImageNet is a database of marked up images maintained by Princeton. It's an open like data set where people on Mechanical Turk were paid to classify pictures. So assign like what is in this picture. And that's a way that it's a data set that a machine learning algorithm can look across and see, okay, here are pictures and here are the topics someone assigned. The classification they used was actually WordNet, and WordNet has a lot of like sexist and racist terms in it. So maybe the way that you can classify people in WordNet is not super great, but we have this data set that's used for a lot of like image classification that is based on that flawed data set. The idea of provenance is not super big in machine learning. So recent paper by Timnit Gebru, Data Sheets for Data Sets, goes into like how documenting what data something was trained on is not really much of a thing in machine learning, but it is in some other fields, and advocates for doing that for machine learning systems so that someone can look and try to see, okay, it came to this conclusion. Does that relate to the data set? The idea of provenance is pretty key to library, to the library field, and also it's a culture in which maintaining record systems over a long time is acknowledged and valued, whereas maybe other fields kind of have, you know, this really older concept from WordNet, which was developed in the 1960s, coming over into this ImageNet, which was developed 20 years ago, coming over into things today. But they are kind of focused on in the moment and don't acknowledge history as much as maybe library science might, since we have archival materials and are thinking about keeping things available into the future. I hope that this helped you get some contextual background on artificial intelligence in libraries. I will stay around for the break in case anyone wants to talk in the Zoom chat or ask any questions.
Thank you so much. That was amazing. I really appreciate how you put so much into context. Yeah, I want to just like clear my schedule and read all of those case studies that you mentioned. I find those super fascinating. Let me see if there are any questions in the chat. We have a few moments until our next scheduled break.
Yeah,
Let me
I'll just
see.
right quick show. Like I put, let me try one that has notes so I don't like, but I put like the notes in these filled out. So like, if you were to go back through them, when slides are posted, you actually, was it not? Okay, there we go, escape. You actually can go and look at like notes, and it has like most
Oh,
of the stuff. Yeah.
awesome.
So,
Yeah. Were you able to upload your slides into Sched?
I can do that right now.
Okay. Or
So
I
I can
can
do
I
it
can
during the
follow up
break.
with you. I don't mean to put you on the
Yeah.
spot. Sorry. Let's see. The chat is full of thanks and praise. Well deserved. Question from Elizabeth McDonald. What is the movement to document provenance? This is a concern of mine.
So data sheets for data sets has been documented or has been cited a lot when it's in the machine learning field. And then in library metadata, my hope is that people would note the source of things. So I think, Mark, if you are in like 670 field, you can put the source of different things. And then in mods, you probably can find like an attribute. Sometimes metadata, it doesn't have a good way to mark things up unless you put it in the part everyone reads. But I would hope that people put source for things in there. And then we have our own problems with like, you know, conscious cataloging, moving and stuff like that. So like our hands are not super clean with like biased metadata either. So but we're aware maybe, or maybe we feel like we should fix it instead of feel like we should make money. So.
It's a very helpful answer. Let's see if there are any follow-up questions related to that. While we wait for any other forthcoming questions, I really appreciated your description of skip logic and how that's been visible and less visible in different systems, especially with the example of TurboTax. I wonder if you have any guidance or suggestions for those of us who work with library faculty or students or users in a public library where they may not realize that certain things are being hidden. They may not know kind of, well, why am I only seeing XYZ job ads? Because things are being predictively kind of scoped based on criteria that they're not aware of. Do you have any like guidance on us for us to maybe demystify that a bit?
Maybe just telling people that it exists. Because yeah, I'll hear stories about people like asking and people don't realize that stuff is sorted. Like, but I guess just telling people.
Spreading the word. Yeah. We did have a follow-up to the provenance question. I guess my concern is the conjunction between provenance and the hidden algorithms.
Can you type like a little bit more? Like if do you mean if the algorithm has made something and now that goes into the real world and it's part of the real world and then it's being reprocessed and treated as reality?
It looks like the response was yes, and the complete non-background of what we see, lack of citation information.
Yeah, well, is something provenance for metadata is something that maybe was not thought of as much when the internet was new. So like Dublin Core, like there's not really a way to put provenance information in, and that standard was made in like 2002. Here, this is a community that works with metadata standards and finding ways to like to say descriptive and provenance metadata have to be the same thing. And it's not just provenance for like your object, it's provenance for like your description of your object and your contextualization. Like having that awareness and putting it into standards as they're revised and changed is probably like something that can fix that over time.
Excellent. Well, thank you so much for a really thoughtful, provocative, comprehensive presentation. Um, I, I hope everyone's brain is as happy as mine with all of the sessions that we've heard over the last 2 days. We will have a brief break and reconvene at 4:40 p.m. Eastern Standard Time. Just in case folks are not able to join the last part of today's programming, which will be a discussion of pre-recorded sessions, I would just like to mention that just as we sent out the link for today's sessions yesterday, you'll receive another link for tomorrow. There will just be one for Wednesday's sessions, but please use that access link to attend tomorrow's content. And we look forward to seeing you in a few moments after the break. Thank you again.